Great, and as we have a pretty full house here for the first Current and ChicagoNEXT Innovator Showcase Series, I'm gonna go ahead and kick us off. So welcome everybody. We're so glad to have so much interest in this really important topic. My name is Elena Harkness. I am the Executive Director of Current. We are the innovation hub for Chicago and Illinois. And we are thrilled to be here thinking about ways that we can continue to build the blue economy here in our region and around the world, even in this time where we're all only able to connect virtually. So this is an exciting new series for us. We've got at least one more event coming up next Wednesday that's going to be featuring blue economy entrepreneurs from our local Chicago and Illinois kind of context. Today's event, we're really excited to bring in innovators that are on our radar from all over the country. They're tackling some of the most pressing challenges facing not only our heavy water users and water innovators here in our region, but around the world. And so we're excited to give them this platform today and to invite our three entrepreneurs to share more about their work. George, can you flip to the agenda slide? Great. So we have a really simple agenda for these Innovator Showcase series. Brief introduction, that's going to be shared by me, Elena, talking about a little bit what we're doing with Current, and our wonderful co-host, Evan Kriakos, who is going to be sharing all about what we've got to look forward to from ChicagoNEXT, which is one of Chicago's most important technology ecosystem partners. Then we're going to cut quickly to the chase, which is hearing from our three leading innovators here: Erin Rothman, the CEO of StormSensor; Ian Robinson, Managing Director of BlueConduit; and Mike App, the VP for Northeast Region for Electro Scan. We'll have Q&A following each one of these presentations, so you'll have time to submit your questions in the chat window during the presentations, and then we'll take those Q&A within the context of the presentation of each one of our innovators. We'll have a very brief wrap up at the end with a couple of ways that you can stay engaged with us, and these webinars will all be recorded and shared up on our website after, so if you want to look back and connect with folks after, there will be ways to do that. Go ahead and advance. Great. So just a few key words about Current and why we're convening this event today. So Current is Chicago's water innovation hub. We were started in 2016, and as a leading partnership between the Metropolitan Water Reclamation District of Chicago, our City of Chicago Water Department Management, and World Business Chicago, which is sort of the parent organization for our partner today, ChicagoNEXT. Our mission is really to make sure that we are growing the blue economy for Chicago and Illinois. And we think about the blue economy as the companies that are developing innovative water tech, like those that are on the phone today or on the video chat today, and also the industries that are using them. And I'll talk more about that in a second, but we're really thinking about the supply and demand sides of the water tech equation and how we can help that market grow more efficiently and effectively for all. We're a nonprofit water innovation hub, and we really function as a local collaborative. So we try to leverage partnerships between utilities, research institutions, industries, and the innovation community for these broader environmental and economic impacts. And I say that we're a collaborative because we really do work at the sort of intersection of these different industries and sectors. We try to fill the gaps and take the lead on projects that none of them would alone and would be sort of naturally squarely in their wheelhouse. And that's really, we look to fill those gaps to make the whole blue economy work more effectively. We are a cross-sector convener, so a lot of what we do is events like this, where we're trying to build stronger networks, organize smart convenings, and ultimately develop pilot projects that help test out technologies in real-world settings. Okay, George, go ahead and advance. So really quickly, this is our working slide to talk about what we think about as involved in this blue economy. On the demand side, we think about all the industries, utilities, and end users that are thinking about how to get more interesting water tech into their operations, to reduce their water use, to manage their water use, and to just generally improve the efficiency and effectiveness of their operations. On the supply side, we think about everybody from universities and big research centers that are thinking about all of the leading research questions and R&D. We're thinking about entrepreneurs, the investment community that cares about that pipeline, and the incubators that are building space for all of these different companies to grow. Go ahead and flip. Next slide. Great. So in order to achieve this blue economy vision, we need several different things to happen. And really today, we're thinking a lot about pillar 2, new tech solutions generated and exported and building these companies. And pillar 5, this is the thriving ecosystem side of what we're doing. So foundational to all of this is understanding what stakeholders need on both the supply and demand sides of our cluster.
A little bit more hands-on, but probably not like.
Ooh, can I pause, make sure everybody's on mute? I'm gonna go ahead and mute you all. Okay, great. Great. Okay. And so really today we're thinking a lot about the needs on both sides of this equation and how to build a thriving ecosystem for all. Go ahead, George. Next slide. And with that, I want to turn it over to Eben to share a little bit about why we're partnering with ChicagoNEXT and what we're going to do to build the blue economy together.
Thank you, Elena. And I want to thank everybody. I want to thank Current for this wonderful opportunity to join their webinar, but also this wonderful opportunity to talk more about Chicago's tech and innovation ecosystem, especially when it comes to the blue economy. Next slide. So my name is Evan Kuriakos. I'm director of ChicagoNEXT at World Business Chicago. World Business Chicago is the city's economic development organization chaired by the mayor. We're a nonprofit public-private partnership that drives inclusive economic growth and job creation, supports business, and promotes Chicago as a leading global city. And one of our important initiatives at World Business Chicago is ChicagoNEXT, which I'm proud to lead as our dedicated initiative to drive inclusive growth and opportunity for Chicago's tech economy and innovation ecosystem. ChicagoNEXT was actually founded by J.B. Pritzker before he became governor as a council that represents the cross-section of Chicago's tech community to ensure that we're convening the multiple members of our tech community to ensure that we're going in the right direction when it comes to sustainable growth and tech economy growth. And we're very happy to be partnered with Current, and we're very happy to have Current as one of our council members. Next slide. I wanted to provide a quick intro about why Chicago leads as a global city for technology, innovation, and entrepreneurship. Chicago startups actually offer the best VC ROI in the nation, according to the most recent update from PitchBook. While deal volume is more significant in Boston and in the West Coast, specifically Silicon Valley, we're seeing the true value of Chicago startups when it comes to offering higher returns. And that's because of our strength as a B2B powerhouse. And uniquely as an affordable global city in the heartland of the United States. Chicago and Illinois universities are the second largest producer of STEM talent in our country, right after California. And that's really to spotlight our world-class universities and everything that they're doing to make sure that they are creating workforce of the future. Chicago is also home to a world-class corporate base. We're third largest concentration of Fortune 500 HQs and over 400 corporate major offices, corporate R&D centers, and other major companies who call Chicago home. We're also home to world-class innovation hubs like Current, 1871, M-Hub, our top-tier universities, and also our national laboratories. And so we have all the necessary assets when it comes to building a really strong and innovative tech ecosystem that's working together to ensure that we are fostering and accelerating innovation in multiple ways. And one of the things that we do want to highlight also is our focus on inclusive growth. We have several initiatives that are dedicated in building a more inclusive tech economy, especially when it comes to a focus on underserved and underrepresented entrepreneurs, people of color, women, military veterans, and especially those communities in Chicago outside our central business district that also could plug into some of the rapid growth that we've seen in our tech economy. And all of this being a big priority for Mayor Lightfoot, especially as you can see here, how she speaks about the need for a 21st century innovation, Chicago serving that role, but making sure that we do that citywide. Next slide. The two highlights I want to kind of share with everyone here is that ChicagoNEXT manages a portfolio of programs that really meet the needs of the local tech community. And what's really also important is two things that we're doing to really respond to COVID-19. One program is Think Chicago, and that's our national STEM talent and attraction program. As we know, the talent pool here in Chicago being the lifeblood of our innovation ecosystem. And it's especially important, especially in this really difficult environment, that we're connecting university talent with tech and innovation career opportunities. And what we've launched is our Spring 2020 resume book, where we've identified tech and innovation companies that are hiring in 2020 and directly connecting them with students. And we're also looking at a series of events later this summer to really make sure that we keep students engaged, especially those who have graduated. We actually just completed a series of webinars with University of Illinois Champaign-Urbana, UIC, and IAT And we're going to continue doing that to make sure that we're highlighting career opportunities for our local students. Especially if your company is hiring in Chicago and specifically university talent, please visit thinkchicago.net for understanding some of these opportunities that companies can engage with. Think Chicago has worked with 50 to 60 technology and innovation companies in the Chicago area in the past 2 years. The second opportunity I want to share is the Chicago Venture Summit. It is the city's flagship VC conference and one of the largest venture events in the Midwest. When it came to 2018, we had the opportunity to bring in 150 investment firms, 1/3 from Chicago, 1/3 from the Midwest, and 1/3 from across the country. And we showcased 108 venture-ready Chicago and Midwest startups who were post-seed, getting ready for their Series A and Series B. We were planning to have our summit actually last week, but we've unfortunately had to postpone it to September 16 and 17. So please look out for the latest updates with chicagoventuresummit.com. And this will be a very fantastic opportunity to showcase our local innovation ecosystem. Of course, we'll partner with Current to make sure we're showcasing our water technology ecosystem during the Venture Summit programming. But please make sure you check out venturesummit.com, chicagoventuresummit.com for the latest updates. Next slide. So Lena, I'll hand it back to you.
Great, thanks so much, Evan. So you can see why it's a natural that we would be partnering with ChicagoNEXT, and we are also really excited to be able to showcase and grow this particular sector of Chicago's technology economy. So we're really excited to be thinking about how to bring great companies to Chicago and to Illinois, and also how to grow our own. And so today we're here to hear from some of the companies that are in the broader national landscape that are doing great things. And with that, I want to turn it over to Erin Rothman, who's the CEO of StormSensor. She'll have 5 minutes to present about her innovative technology, and then we will have some Q&A time for Erin. Erin, take it away.
Awesome, thank you. So my name is Erin Rothman. I am the CEO of StormSensor, and I built this company so we can provide cities with the insights that you need to build resilient, sustainable communities. Next slide, please. Urban flooding has been in the news a lot lately because of climate change. Heavy rain events have increased between 9 and 55% since 1958. Overall, our sewer systems, which are basically the entire drainage systems for our cities, were designed for less rain, less people, and less pavement. And according to NOAA, cumulative losses from flooding and tropical storms in the last decade totaled $500 billion. And then there's sea level rise. The Great Lakes are currently setting or approaching all-time high water levels. And then the impact to property values due to sea level rise along the East Coast alone is over $14 billion. So if you add increased rain to rising water levels, then you get what we have today. 75% of declared disasters are from flooding, and with over 1 million miles of sewer lines in the US, an anticipated $1.4 trillion will be required to upgrade stormwater and wastewater infrastructure as a result of aging, overuse, climate change, and water quality issues. But the sources of the problem within the sewers, which are basically our last unmetered utility, remain a black box. Next slide. StormSensor developed cloud-based network sensors that monitor temperature, flow, velocity, and depth. And our software maps how water moves through these sewer systems in real time. So the larger the data or the sensor network, the more value to our customers. Our software tracks sewer flow data, so think Google Traffic Maps for sewer and stormwater systems. Our insights give your communities the information you need to measure the risks you face from flooding and manage the impacts. Terrapin Basic is our municipal-focused data platform that's in market now. Terrapin AI is in process, and cities can use that software to identify issues like flooding, backups, and sewer overflows before they hit, saving hundreds of thousands, if not millions of dollars with each storm. Oh, and one more thing. Based on the data that we've developed so far and conversations that we've had with our customers, we already know where we're going next. So we're building a software package called Dynamic Flow that will be released next year. And this software visualizes in real time, using actual data, the intensity of rainfall as storms are currently moving through communities, the water rising within the pipes using data generated from our sensors, and then also monitoring and incorporating tides and winds that impact surface water so we can watch and ultimately model using empirical data in real time the impacts that storms are having within our communities. Socioeconomic and property value overlays will help direct priorities to those areas that need it most. Next slide, please. And then every city needs this. There are 11,500 cities and counties in the US alone. Our target market, or our beachhead market, is the 769 cities in the US with populations over 50,000 people, which we've qualified based on location indicating risk to sea, lake, and river level rises, as well as repeat flooding. Of these, 306 of them have populations over 100,000 people, which we've further qualified based on city traits like their stated focus, budgets, and early adopter status. And then why do we know or think this market is worth going after? Overall, there are 132 communities on the Great Lakes that are all at or near record water levels. 90 communities along the East and Gulf Coast face chronic coastal flooding right now, and up to 700 communities across the United States or coastal United States will face effective inundation issues by 2100. And then there's another set of customers with older combined sewer system, of which there are 860 in the US. And as sewage overflows are a major pollution issue, 14 states have public notification laws. Overall, there are 45 EPA consent decrees with a ton more attention at the state and local levels within those systems. And then our Terrapin Basics software package already has a feature set ready-made to address those CSO concerns. And we're capturing this market by introducing a new paradigm, sensor networks, like actual lots and lots and lots of sensors, to our customers. So you start with a network of 5 or 10 sensors. We sell in minimum networks of 5. And then you buy 10 more or 40 more or 50 more. The initial sales cycle is between 4 and 7 months. The follow-on expansions take about 4 months to close. And we have about $6 million in our qualified pipeline. We're closing new projects and new communities almost weekly. By the end of this year, we'll have deployed more than 200 sensors in 25 cities. Each network costs our customers just over $1,000 per sensor per year, and that includes everything from the software to the sensors and the gateways. And we've raised $4.5 million from investors across the country to help ensure our success, and we just closed a round last week. Next slide, which is the last slide. Flooding is going to be the most widespread ramification of climate change across the globe. It is heartbreaking, it costs people their jobs and their homes, and the emotional and financial impacts are extraordinary. At StormSensor, we believe that we must look forward, we must build for resiliency, and we must work together to get there, because together we will change the world of water. Thank you.
Great. Thanks so much, Erin. So now I'm going to open it up to Q&A, and just a reminder that we want to make sure that you're putting your Q&A into the group chat, because we're going to be reading those off. So I'd love to start it off with just a question about what are the most common questions you're getting from municipalities when you're out there in the sales cycle? Like, what are the things that are top of mind for them? Yeah, how would you sort of boil down the FAQs?
Yeah, so the biggest thing is obviously what our sensors monitor, how much they cost, how easy they are to install, and what they do. Most of the projects that we do tend to start with a model validation study or stormwater model validation study and then move into something else. So for example, in Memphis, they're doing a model validation because they have significant flooding. So they're trying to understand what the capacity issues are within their storm drains. Yep. Turns out that the Mississippi River, unbeknownst to the city, was flowing over a mile into their storm drains, so taking up over half the capacity times. Mm-hmm. And the plant who opened up the floodgates didn't know that it was going so far inland. The city had no idea that they were doing that in the first place. And once they were able to use our software to watch it, they could see the water level rise, watch a storm coming, close the gates, open up capacity, and stop flooding. Yeah. So it's pretty simple. It's just, it was very hard to build in the first place. And once it's done, it makes us, it clears a lot up for what's going on down there. Yep.
Great. We've got a question from David Rankin, wondering how the sensors integrate with controls and what actions they empower.
So right now, we do not build the integrations ourselves for the real-time controls. However, we do a couple of things. We provide notifications. Right now, we offer 4. You can receive via text or email, and those include dry weather flow, wet weather flow, critical depth, which we use for urban flooding, and then CSOs. We also provide our data, if you like, via an API, and then you can use that API and that data to trigger real-time controls within the software of your choice.
Great. And then we've got a question from Dean. Are you working with any local municipalities to date?
We are in Deerfield right now, so just down the road from you guys. And then we're also looking at Evanston. We do a lot of work right now with Christopher Burke Engineering Associates, and they're based just outside of Deerfield. So okay. Amazing. And also I grew up in Joliet and my family's from Milwaukee. So I spent like the bulk of my life going in or through Chicago.
Love it. Well, we were going to count you in the blue economy Chicago, Illinois family too then, by extension. Great. Thanks so much, Erin. That was wonderful. Now we're going to flip over to our next presenter. Erin Robinson is the Managing Director of BlueConduit. Ian, take it away.
All right, great. Thank you very much, Elena and Current, for letting us present. So as Elena said, my name is Ian. I am the Managing Director of BlueConduit. And what we do at BlueConduit is we use machine learning to help cities get a better sense of how many lead service lines they have and where they're located. So why does this matter? First is that utilities are increasingly required to know what their lead service lines are. A good sense. Oh,
sorry. Overzealous muting, that's my fault.
No worries. All right. So lead service lines have been in the news in recent years, and they are increasingly both a major public health concern and also a major infrastructure question. So the cost of replacing the lead service lines over the next few decades is estimated to cost about $30 billion. And there is increasing both public pressure and regulatory pressure for all utilities to accurately report and efficiently replace their lead service lines. The water crises in Flint, Newark, and Washington, D.C. have raised awareness of the risk that lead service lines play in the role in providing safe drinking water. And so increasing realization that in addition to corrosion control, which plays a really important role, that removing the lead service lines is the only way to completely eliminate that risk from the drinking water systems. Mm-hmm. And also that there is increased regulation, both the new EPA lead and copper rule revisions, and then increasingly state by state. You see Michigan, Wisconsin, Illinois, New Jersey are all doing things that are requiring utilities to put an even, to communicate and report what they have in their systems. The biggest challenge with this is that utilities are using outdated, incomplete, and inaccurate records to make these decisions. So those examples right there are what we found when working in Flint, Michigan, of what the city of Flint had that they were making those decisions on, which were old records or ironically waterlogged books of maps. And this is the information that's being used to inform both budgeting, capital planning, compliance, and public communication. So this is going to cost billions of dollars in the coming decades, and we want to help cities do this in the most efficient way possible that also protects public health. So there's a giant gap in preventing them from doing so, and this gap, though, is not unique to Flint. It's something that these methods that we used in Flint, which I'll talk about next, are things that are facing all cities in the country, actually. So if you go to the next slide. So about how we got into this field is in 2016, our two co-founders, who are data science professors from the University of Michigan, wanted to help in Flint. They had no water experience, but they understood that data would play a key role in this, and they wanted to see how they could help. So they spoke to the decision makers in the replacement project, and they came across these two big challenges. One was they didn't know how many lead pipes the city of Flint had, and the other was they didn't know which pipes had lead and which ones did not. And so by helping the city of Flint answer these questions, they were able to develop this use case for machine learning that ended up saving over $20 million in the replacement project, and more importantly, really accelerated the removal of the lead service lines. So just to go through this at a very high level, when Eric and Jake, the co-founders, went to Flint first, the historical records suggested that maybe 10 to 20% of the city's 50,000 pipes were made of lead. Now, after digging a few precise holes at a representative sample of homes across the city, they estimated that 40% of the city's pipes would be lead. And so now, after 20,000 excavations have occurred, the percentage of homes that have lead pipes in Flint remains, the estimate is at 40%, so right on what they had done a long time ago. And what this information allowed them to do was to budget how much would it cost to replace the city's lead pipes. And the other question is, well, where do you go next? Where do you go and where do you go next? So how do you use this information to prioritize which homes you target for replacement? And so throughout 2016 and 17, the city of Flint's teams used this predictive model that the researchers from U of M developed, and they had an 80% accuracy or hit rate. So for every home that they went to with the intent of replacing, 80% of the time they replaced the pipe. They found a lead pipe that needed replacing. 2018, an external consulting firm came in and took over the project. They did not use the predictive model, and their hit rate went down to 15%. They had a different prioritization method, which meant that they were digging a lot of holes that they found copper and not finding lead at many places. There was a federal court settlement at the end of 2018 that mandated the city return to using the predictive model, and the hit rate went back up to 60 or 70%, which is exactly where the model would have predicted. So this same method that the team used in Flint, those methods and those learnings are replicable to everywhere else. And what we do at BlueConduit is to take that method and help other cities work through these challenges. Next slide. And so what we do at BlueConduit is making actionable data for large drinking water utilities with this question. So how does the model work? Well, it takes that representative sample that I had talked about before and layering on all of the parcel level data and other information we can find about the individual homes to be able to generate home by home probabilities of the likelihood of lead. So that image on the right, which is taking these database, building a machine learning model, which they published these methods and received recognition in the data science and the water community for, and turning it into home by home probabilities. Well, this is a huge need, and there are many cities that, that this could help. First off, all cities within the next few years are going to be required to report their lead service lines, what they know and what they don't know, to the EPA. And that's going to be public. There's some amount of notification that they need to do to residents, and also an increased of replacing those existing lead service lines on a state-by-state basis, and otherwise cities need to find a way to do this. And there are 4,000 drinking water utilities with more than 10,000 inhabitants, and those are the kinds of, that's the kind of utility that we are targeting is greater than that amount of residents. And really why this matters is the longer that it takes cities to get an accurate count and plan to replace their lead service lines, the longer the lead risk continues, and the greater, and then they cannot integrate this information into their long-term planning and budgeting. We're already working with 30 cities across the country to help them do this. And what we're doing is we're hoping to bring this solution to more cities to help them better manage the uncertainty of what their lead service lines, how many they have and where they're located. Next slide. And so that's what we do at BlueConduit. We're looking forward to helping bring this solution to more cities to help them get the lead out of their drinking water systems quicker and getting a better sense of what they have in their systems. Thank you very much.
Ian, thank you so much for that. And just keeping up track of time, I'm going to ask people to please make sure you submit your questions on the group chat, and Ian will be able to respond to you directly. And Ian, thanks again. And to make sure we're keeping track on time, we'll go to our next presenter. So I'm really excited to introduce Mike App, VP of Northeast Region for Electro Scan. Mike.
Thank you very much. I appreciate the time this morning, and obviously I would have liked to see you all face to face. I also am a Chicago kid. I grew up in Evanston. So even though I live here in upstate New York, what our technology does is it kind of follows what Erin does. Erin works on the sensor network for the cities, for CSOs. We actually go in on a granular level to work with utilities on both the wastewater and potable water side to determine what the sources of their infiltration and inflow is, which causes CSOs and SSOs. On the foul water side, as well as on the potable side, determine where their NRW, non-revenue water loss, happens to be. And one of the issues that you see here on the first screen is that many municipalities on the wastewater side in particular are still using technology and data that was created back in the 60s, 70s, and 80s. And what's happening is that by using these legacy technologies, they're unfortunately getting not accurate data of what's actually happening. And what you can see from the two demonstrations on the pictures below, the The map on the left is from a mid-sized US city that had a plan to do a rehabilitation in one of their basins that was used by, they primarily used legacy technologies to make the determination of where to go. The original plan was to have a 50% reduction in inflow and I&I on the wastewater side, and they spent $22 million in the process of doing it. Unfortunately, they actually only had a result of less than 20%. And the reason was they simply chose the wrong lines of where they actually needed to go. The graph on the right shows in red where actually they should have picked the lines in which they were going to rehab. So what we use is our technology works when the systems are totally intact. While the systems are operational, we're not impacting any customers, neighbors, businesses, and we're able to generate this through machine intelligence within minutes as we come back. Next slide, please. So what is it that's become so important? What's become so important is back in the 70s and 80s and 90s, when I used to work in the construction field, municipalities had lots of money, just go out and, let's work here, work there. Unfortunately today, the CapEx and capital expenditure dollars with the amount of money that's being generated from ratepayers is not an endless pool of money like it used to be. So what's happened now is that agencies and utilities, both on the water and wastewater side, have got to use machine type intelligence to get accurate positioning of what you're going to do and where you're going to make these actual investments on your system, so that you can report that you're receiving a return on those investments, but more importantly, you're removing the water or the loss of water from your system. On the left-hand side, you can see a 15x multiplier by using these types of technologies. $5 in deferred maintenance, $4 in accepting poor rehabilitation work, $3 per gallon, now it's selecting the wrong pipe, $2 for heads-up location of pipe damages, $1 pumping and treatment costs. And the pumping and treatment costs are the things that no one pays attention to. Every gallon that comes into the system on the wastewater side or is lost on the potable side has electricity, chemicals, processing, and those costs are constantly baked in and have to be dealt with. So the nice thing is about our technology is that we can maximize limited capital resources by prioritizing rehabilitation to don't fix what's not broken, verify that work completed conforms to your contract of water tightness requirements, using real-time inspection results. This is critical for what we do. When we actually perform a scan, the data is back on a worldwide basis within 3 to 5 minutes. So our clients are actually able to see us work in real time and make real-time accurate decisions instead of waiting months for a report to come back in, and now you've lost a construction season. Next slide, please. So this slide is busy, I apologize, but I was trying to make sure you all had enough ideas of what we can do. Obviously on the right, I said don't use 80s technology to make comprehensive decisions in 2020. Comprehensive fell inspections. We actually have an ASTM standard, it's F255018. It's focused electrode leak location. That's what the US EPA officially knows us as. We've been benchmark tested by the US EPA in 3 different studies. We've been included in every consent decree since 2014. We've also been benchmarked by Water Research Council in England, IKT in Germany. We have worldwide patents for water tightness in Japan. But the one thing is that the technology is 100% repeatable and it's unbiased machine intelligent data collection. All of the data is compatible with all the software applications for hydraulic modeling, GIS, ERSI, and also Innovators is one of our partners. What this technology does is provide utility owners with precise pipeline defect condition information to determine their flow rates before and after. So again, they can ensure return on their investment for the ratepayers. More importantly, our technology is accurate down to about 1 centimeter of location, and every defect has an estimated gallons per minute or liters per second attached to it. On the upper left-hand side, you see what one of our reports actually looks like. We are a software-based company, and because of that, if you can play solitaire or golf on your phone, you can run our equipment. More importantly, anybody can read our equipment. So what happens is that when you, based on the ASTM standard, there's small, medium, and large defects. the percent of the pipe that's defective. On the graph situation, we see those tall yellow spires in the horizontal axis. Those are actually defects. We actually use an electrical field that we emit from our probes that scan the inside of the pipes at all times. If there's an open fracture in the pipe, the electricity gets back to ground, it completes the circuit. The theoretical light bulb lights, we measure how bright and how long they stay lit for. We're now able to determine the size of the defects under the curve, and then we extrapolate a gallons per minute estimate through Torricelli's law. The bottom graph is the importance of showing what happens with legacy technologies and when you use machine intelligence. The top graph in blue, where you see the red box around it, the worst pipe based off of a legacy technology was that pipe. Any engineer using those types of technologies would immediately go to that pipe and be the first one in which you would rehabilitate. Unfortunately, when you use machine intelligence in our system, you actually find it was the best of all the pipes that were scanned in that group. Unfortunately, this is a case of where the utility would spend money in a place where it shouldn't be. The biggest thing we help utilities to do is we don't fix what's not broken. Our current space that we're working in, we actually just sold a unit to a town of 7,000 people in Tennessee. And we work as high as up to San Francisco Public Utilities. So it doesn't matter who or where anybody is, we all can use the technology. And like I said, we work worldwide. I appreciate your time and thank you very much.
Great. Thanks so much, Mike. Everyone, please submit your questions if you have more. I did want to ask, as you kind of seek to bring this to scale as a set of software offerings, what are some of the challenges that the business is facing? Like, what are you struggling with?
The biggest thing is that one of the things, because we're very unique, we're very nimble, we're 20 people, we actually do all of our own coding, we do all our own hardware and manufacturing all in-house. The biggest thing is that, like any status disruptor, new products disruption coming to the market space, the legacy and the way things have always been done is very tough to break. Well, we've done it this way for 30 years. Why are we going to change now? Well, because it's not, the 1990s anymore. So that's the biggest thing in which we deal with is just, we've always done it this way. But where you see our early adopters, the San Franciscos, the Hillsborough counties, the Lombards, the Springfields in Illinois, what you see for them is, I got to get off the wheel in the rat race. I've done it this way for 20 years and I haven't gotten where I need to get to. Mm-hmm. And the state or the federal governments are still on top of me and I have to explain all of that. Mm-hmm. So that's where, it's turning the cruise ship, so to speak, is the biggest thing. So.
Mm-hmm. Interesting. And where are you in your funding rounds? Like, what funding are you looking for at this stage to grow?
Right now, we are in the process of bringing three new probes into the market space. I'm sure there'll be another round going out here shortly. But basically, the biggest thing we're trying to do is, because we do everything in-house, we work with the clients, which we have now, figure out exactly what they want on the software side as well as the hardware side. And then we bring that product to market. I think that's what our clients are looking for. So I'm sure there'll be another round coming out.
Great. Excellent. Well, thank you so much. Thank you, Mike. And thanks to all our presenters. George, if you want to flip to the final slide, I'm going to keep us on track to wrap up on time today. There's a lot of ways that you can stay engaged with us. So first of all, today's Innovator Showcase was the first in what we expect will be a series. There are so many companies out there that are growing and building really exciting technology that can help to meet our needs and solve our challenges with water. And we're excited to bring them to you. So if you know of a company you'd like to see a pitch from, share them, put them in touch with us. We would love to be doing more of these. Please join us next week, same time on Wednesday, May 6th for our next in the Showcase series. We're really excited to be featuring Chicago and Illinois-based entrepreneurs that are building their companies right here in Chicago. You can also join us on the 13th of May for a fireside chat and book talk with Seth Siegel, who's recently written a book called Troubled Water, What's Wrong with What We Drink. We're really excited to bring him virtually to all of you. And as Evan said, there's going to be a lot more virtual events coming up. So please stay tuned and follow along with ChicagoNEXT if you're interested in some of the opportunities to build the tech ecosystem and engage with our tech ecosystem here in Chicago and in Illinois. If you scan this QR code on your screen with your phone, it will take you straight to our events page where you can learn more about our events as we add new ones all the time. And you can always reach out to my fabulous colleague, George Brigandy, who is the mastermind of all of our virtual events and has been putting this together for us today. His address is on your screen. And I'll just draw your attention to the group chat right now. Evan's got the LinkedIn page for ChicagoNEXT up. They are adding new events all the time. And as he said before, please share your opportunities for internships, jobs. We are also collecting those as well as we try to build as many new opportunities for students and new promising water workforce employees as we are all navigating these challenging times together. So I will leave it there. I'm so grateful for this wonderful group today. Please be in touch with us, pitch your ideas for collaboration, and we will see you next time for the next installment of the Innovator Showcase. Thanks so much, everyone. Have a great day.